Welcome to this session under the hood, the Snowflake Native App Framework. My name is Kevin McGinley. I am a technical director on the Snowcat team at Snowflake, special team on our product org. I've been at Snowflake for 5 years, and I am joined by a distinguished guest from our engineering team. Why don't you introduce yourself, Scott?
Hey, I'm Scott Gray, a principal engineer on the Native Apps team, and I am super excited to be lifting the covers on what we've been working on so hard for the last 2 years, really.
Awesome. So we'll kind of walk through some things from a sort of pictorial diagram perspective, kind of get you oriented. Then we're going to go through a code walkthrough. Then I will do a pretty extensive demo. So quick show of hands. How many of you watched the keynote this morning, either live in person or on the stream? Perfect. Okay, so we're going to be taking what you saw in that demonstration by Unmesh and Dash, and we're going to be kind of taking a peek inside that app and talk about how it works. Okay, so let's kind of take you through at a high level though. Let's kind of get everybody oriented to all the different parts and pieces that we have going on in the Snowflake Native App Framework. So first and foremost, the idea here is that we want you to be able to build apps that are native to Snowflake that can run inside Snowflake. We want you to be able to distribute and monetize them on the marketplace. And if I'm a consumer of your application, it should be really easy for me to just go out to the marketplace and install your app in my account. Now, benefits to you as an app builder, we're going to protect your IP. From the consumer standpoint, they're going to be able to restrict your app from doing things within their Snowflake account. And we'll actually show how you as an app provider can ask for those permissions. So I will be giving another session later this week on Thursday that talk about our different deployment models within Snowflake. And I just wanted to quick orient everybody to the different application deployment models that we have in Snowflake. So the first one we talk about is called managed. This is where you as a provider have full control over the entire experience. You're going to run your own Snowflake account with your own cloud service layer for processing. You're going to have your own UI that you host and that application customers will connect to. We then have our connected, where we start to shift some of the responsibility to the consumer. In the connected app use case, we're shifting the ownership of the data and the Snowflake account to the consumer. So now your app runs inside the consumer account, but there's still probably a huge amount of fundamentals that are outside of their account. There are parts of the application that have to run in your environment as well. That's the connected model. What we're introducing with the Snowflake Native App model is that everything, the entire application, minus maybe an external function call that I'll mention in a second, can run inside the consumer Snowflake account without you needing to access their Snowflake account. So in the connected model, you have credentials to log into their environment. In the Snowflake Native, you do not. You build a wholly self-running application that can run in their account. So what's this look like 50,000 foot level sort of pictorially? So we start in your account as a provider. You're going to build something called an application package. You're going to hear this term over and over again, and you have full control over what you put in there. And we'll talk about the Snowflake primitives that we support and that are coming over time. You can also incorporate reference data. So the marketplace has always been a way to share data, have a data product. Now we can combine data and application code together into one application package, and we'll see that in action. From a marketplace perspective, you can create either a public listing or a private listing. Public listing will go out to, may be available to all Snowflake customers. Private listing, you're going to specify a specific account to have access to your application. And of course, you have the ability to monetize using the abilities on the marketplace to do so. From a consumer's perspective, they're going to install an application that can interact both with their local data as well as any external call out that you might have. This was the external function comment that I just made a couple minutes ago, where maybe you have an API that you are hosting that you want the application to interact with. We do allow for that capability. Otherwise, everything is running inside the consumer account. So all of this is controlled, your IP is protected. You do have a local database environment that you create data, interact with that data, expose that data as you choose. And you have the ability to make enhancements to your application, and we will push upgrades out to the consumers for you. We'll talk about this in a little bit more detail. We also have a mechanism for you to have logging and trace events within your application so that when you do have an issue with a particular consumer, you have the ability to see the logs of what was running in your application so that you can better support them. So the idea here is that consumer data stays put. Their data does not have to leave their environment, which is highly appealing to them as a Snowflake customer. They're paying for the compute. You don't have to worry about that. We give you the telemetry data. You get to control what the app interface is, how the database is set up, what's going on in that database, and that's all protected. And of course, the push upgrades that I talked about. Now I'm going to turn it over to Scott, and he's going to walk us through a little bit deeper level here with this diagram.
Thanks, Kevin. Yeah, I'm going to take you through this diagram kind of in two passes. First, just covering the sort of core components that make up native apps, and then going just one layer deeper into the fundamental moving parts. And then I'm going to hand it back over to Kevin, and he's actually going to walk you through the detailed implementation of an application. So at its heart, an application is just a bunch of files. Files are convenient largely for source code control, and also they fit well into various CI/CD pipelines. So versions are, once you've created those files, you package them up as versions. The provider has the ability to then indicate who gets what versions, and we'll be taking you through that in some detail. And those files, those versions, are then subsequently installed in the consumer's accounts as an application. Kevin mentioned a couple times that the application, that part of our framework is about protecting the provider's IP, intellectual property. So what does that mean? It means that the consumer can't see the implementation. So even if they can call stored procedures, they can't see the body of the implementation. They can't see the queries. They can see the queries are run, but they can't see the details of the queries that are executed. And amongst other things. So we're gone to great lengths to make sure that the provider itself is protected. And finally, an application can be made up of a shared component, shared data, much like sharing in the marketplace today. So this allows the application provider to set up a set of tables or views that they want available in every application instance. The application itself, following along in this IP protection strategy, the tables themselves are still not visible to the consumer unless the application explicitly says so. So this allows your application to have a mixture of maybe some internal data that's feeding processing and then data it wants to externalize to the consumer. So we've got, half the walled garden here, making sure the provider is protected, but how do you protect the consumer? So the application itself is just a database, but it's a special database. And part of it is anything running inside of that database can't touch anything else inside of the consumer's environment unless the consumer explicitly says so, via grants, via some other mechanisms that we'll touch on during the presentation. So let's go one level deeper. I mentioned that an application is a bunch of files. Well, so first of all, an application can be made up of any of the existing Snowflake primitives, or most. I think there are a handful that might be restricted. So you kind of build your application using these primitives, and then you package that up in files, the first of which is a manifest file. The manifest provides metadata about the application, including basic stuff like what's the name of the application, the name of the version, as well as publishing details about requirements that the application needs to run inside of the consumer's environment, what permissions it needs, what sort of data it needs access to. So all of this feeds into the definition of a version of the application. Secondly, there's a setup script. So this is the application. This is the DDL statements that create these primitives, these Snowflake primitives, in the consumer's environment when they install the application. The script is also written in a manner that it's idempotent, which is a fancy way of saying that it can be rerun. But part of that strategy is it's trying to reach a target state. So it's not just your install script, but it's also your upgrade script. And finally, you can include any additional files that your application may need to function. So for example, if you're using Streamlit, if you're using Snowpark, Java, Python, then you may also need support files for that, like Python modules and Java jars, and including just data files that might be needed by the application. So all of this is packaged up. And it's packaged up in a very formal manner where now I'll touch on, Kevin mentioned the term application package. So we have a new Snowflake object type called an application package. This is used to internalize these files into declared versions or declared patches of the application. Additionally, the application provider has special commands, special tools that they can use to define what we call release directives, where they can indicate which consumers will get which versions of the application. And once they define that, as soon as they define that, that version will begin automatically rolling out to all of the consumers of the application that are targeted to the new version you've just released. All right, so we have an application package. On the other side of the fence, we have another new object type in Snowflake called, conveniently, an application. So when you install an application, it's just a database. It's populated by running this setup script. But we also introduced another new concept into Snowflake, which is a version schema. So this is a really fundamentally important part of the upgrade strategy, because part of what we wanted to allow for was live upgrades. So the application can be used during the upgrade process. So what a version schema does, it has very special semantics where the contents of the schema are directly tied to the version of the application. So for example, when an application is upgrading, the upgrade script is creating things in the version schema. But the people using the application can't see anything that's being created at that time. They continue to see the state of that schema as of the version of the application when they started accessing it during the upgrade. And similarly, so as soon as the upgrade finishes, there's an immediate swap where any new requests start seeing the new version of the application, the new contents of that schema. But any long-running queries that may have been started either before the upgrade or during the upgrade will continue to see the state of that schema as of the time they began running the query. So again, this is a really fundamentally important part of this kind of live upgrade process. And the traditional, we say unversion, but it's really just a schema. Your traditional schema is still there and still usable to maintain state information, to maintain data or functions that you want to persist from version to version of the application. So in all of these diagrams, we've been showing the application as provider and consumer, but it's also worth noting that the provider itself can be its own consumer, and this is a really important part of our development model, some of which Kevin will touch on as he goes through his demo and presentation. So with that, I'm going to hand it back over to Kevin.
Awesome. Okay. So now that you've kind of seen this in diagram format, let's actually start seeing it a little bit in the SQL syntax or the code of what you're doing. So first things first, you're going to build with Snowflake primitives. This is a stored procedure. We support lots of different primitives that you can put into an application. You're going to build those things like you normally would, probably in some sort of dev database. You're going to build them, test them, make sure that they work independently of each other. And then you've got a collection of procedures, functions, whatever, that make up something that can become an application package. Before we do that, though, we're going to create that setup script file. So what you're doing in the setup script, and most likely most of you smart people in the room are going to automate this part, but you're going to wrap all of those DDL statements that you have for your individual objects into one file that also includes some key components. The first is on line 2 there that you see there where Scott talked about this version schema. So we're going to apply the version schema to the application where appropriate, because not all schemas within an application have to be versioned. And then we're also going to do the step where you are going to, as a provider, take control over what gets exposed to the consumers. So you're going to create application roles and then grant those roles permissions to do things within the application. That's lines 1, 3, and 12. So here, what we're doing is we're creating an application role. We are granting it access to the schema where the procedure resides and the ability to call the schema itself. Then we're going to build our manifest file. Now, during the demo, you're going to see a more robust manifest file that does different things, but here you're basically describing the application version and the core components therein. Notice on line 8 there, we're pointing to where our setup script is. The manifest needs to know that so that it can run that at installation and upgrade time. Then what you're going to do is create the application package and a stage inside the application package where you're going to put all of your files that Scott referenced earlier. So we're going to put those in a stage, and at the time that we create either a running instance of the application or a version, we are going to take those files and put them into a sort of secret hidden area that we run the application from. So think of this as code staging, not this is the live code that your application runs off of. Okay, so this is a staging step to compile your application. Okay, and you can see there that we're running the put statements to do that. I'll show you a different way during the demo. So then there's a couple different ways that you can create an application. The first way is by calling those files directly themselves. So in this instance, you can see I'm calling an application. I'm creating an application from a package using my stage location. And in line 4, I've got something called debug mode equals true turned on. So this is in the provider account. You have the ability to run the app in debug mode. So all of those protections that we put in place so your consumers can't see your IP, when debug mode is on, you can see all those things so you can test your application instance. Then what you're going to do is create a version. Here you're going to solidify a set of files as, okay, this represents a version and patch number. When you create a version for the first time, we automatically set the patch at 0, and we will auto increment from there, as you'll see on the next screen. And you can also create an application from the version number itself. So you see that on lines 4, 5, and 6. Once we're good to go there, we're going to go ahead and add a patch for the application. So let's say we need to make some enhancements. We go ahead and add a patch. Here, you don't need to specify any numbers. We will auto increment those for you. So whatever the latest patch number is, we'll just automatically add the next one in line. You can show the versions and their associated patch numbers. And then ultimately, you can set what's called a release directive. So this is in lines 5, 6, and 7, where you can say, I want all existing customers or consumers and anyone who installs this application new to get version 1, patch 1. So that's how you're going to control, as a provider, what version of the app gets installed. And you can make exceptions for certain customers if you need to. We're not going to show that today, though. Let's go over to my laptop because we're going to look at a demo. Okay. So again, this is the application you saw in the keynote this morning. And what I'm going to do is I'm going to start on the consumer side. So Dash showed a little bit of installing the application. I'm going to show the sort of totality of it. So here you can see that we've got an app called Ski Goggles Summit Demo. This is not in the marketplace. This is an app that is shared directly from my provider account directly to this consumer account. So this is the private listing that I talked about earlier. You can see it's on version 1.0, and I can click this blue Get button. There is the ability to give the application a different name if you want and choose the warehouse that's going to do the installation. I'm not going to bother with that. I'm just going to go ahead and click Get. And what's happening right now is the setup script is running. So the setup script will run. Once it's complete, you now get this successfully installed, and I can open the application. This is going to pop open another window here and launch the default Streamlit, which I'll show you in a second. And in this instance, let me make this a little bit bigger for you. The application is asking for permissions on certain tables within the consumer account. And you can see here it says grant select on orders table. I need an orders table to do that. So I'm going to come in here into my consumer database and say, okay, here is that orders table that you're looking for application. I'm going to grant you permission to use this table. And when I click save, you're going to see privilege successfully granted. So it automatically created that grant and ran it on behalf of the consumer. We also want a second table here. So you can specify a number of objects that your application needs access to within the consumer account. And then once you've got those objects, you can go ahead and reference them in your application. So I, as the provider, don't know what the table names, database names, schema names are, but I can create references that once the consumer populates them, they'll be usable. Oh man, Scott, we just got punked. Ski Googles, pink charts. Unmesh and Dash were clearly playing a joke on us here, but no worries. We have the ability to pack application. So we will go through and fix this snafu of an application that they gave to us. Okay, so to do that, let me hop from the consumer side over to the provider side. So this diagram is what we were showing you earlier. So what I want to do is kind of reference what's going on here on the provider side within the context of Snowsight. So we're going to look at these objects within Snowsight and just kind of orient you to the Snowsight experience before jumping into a VS Code environment and show it to you from that angle as well. Okay? So I'm going to shrink this down a little bit so you know what we're talking about. And we're going to kind of just start here. We've got, whoops, that's a little wonky. Why is that? Let's refresh that. There we go. So the first thing is we have this reference database. And in this reference database, we have a table that we want to share as part of the application. Now, we have this outside of the application package because more than likely, if you're a pretty sophisticated app developer and you're including data as part of your app, you're managing the workflow of that data in a separate environment by a different team, running pipelines, managing quality control, etc. So we're going to let you run and manage all of the data that you're used to sharing or want to share in its own environment, in its own place, but we will reference it within the application package so that you can use it and share it across as part of the application installation. So that's what we're talking about right here. We've got our reference data. In this case, we've got a shipping table that we're including as part of the application that gets used in that final Streamlit dashboard. Okay? So then we're going to come over to our dev database here. More than likely, like I said, you're going to have a team of developers. Maybe you have a highly automated dev environment where you spin up stuff, maybe a database per developer. Maybe you spin up test data for each developer. This dev database represents, first here, our test schema. So we need, remember that orders and site recovery table that I pointed to in the consumer account? Well, when I'm building my application, I need sample data of both of those tables to make sure my code works. So I've got those here in my dev database. I also have my code. So you can see here I've got individual procedures, I've got individual functions. All of these things, maybe one or more developers went through and built and tested independently of each other. I also have a stage in here that has a stage called libraries. You're going to see this library stage a little bit later. This has a number of UDFs and Python procs in here as well. And then notice too, there was another stage. This is a cryptically named stage. This is where my Streamlit and Snowflake file is built. So that Streamlit that you saw earlier was using Streamlit and Snowflake functionality. When I built that, I saved it into a stage in my dev database. Okay. So now let's look at the application package. And you'll notice it has a different icon here. So the application package, I'm in the database area of, or the database browser within Snowsight right now. So when I drill into this, it looks like a database. It feels like a database because it is. But we're denoting it with that special icon, and I'm going to show you another screen in a little bit later, which shows the sort of uniqueness of what an application package is compared to other databases. But I can browse what's in here. You can see in my shared content schema, I've got a view that points to that reference data. So this section up here is the view that's pointed to that shipping data. And I have code in my application that says that this view is going to be part of the shipping version of the application. from a shared data perspective. I also have a code directory. Here is where I'm going to do that staging of all of my files. So my stage is called demo app stage. And if I drill in here, you can see I've got a folder structure going. I've got version 99, ignore that. That's to help me reset the demo. But then I got version 1.0. And if I drill into that, I can start to see files and directories of other files that make up my application. Now remember, this is just for staging. So how you manage this is entirely up to you. You may create a folder structure like this for different versions. You may do something else. You may only keep one version there at a time and just overwrite it every time. It's totally up to you how you want to stage your code. And it does not have any link to source control or anything yet. Okay, so now that we've taken a look at that, let's actually kind of drill into the files in a little bit more detail. So I'm going to switch over to VS Code here. And in VS Code, you can see I've got this same v_00 directory. I've also got my same v99. We'll take a look at this v101 here in a second. But you can see the first thing that we're going to look at is the manifest. So let's look at a little bit more details that we didn't see before. So before you kind of saw lines 4 through 11, that was in the code walkthrough. But now we've got a little bit more detail that we can show you in here. We've got, hey, the ability to set our default streamlet, which streamlet is going to launch when the app launches. What is my default log level or trace level? Here is how you set the references for those objects that you want access to in the consumer account. So you can see here, I want an orders table. I want a site recovery table. My privileges are select. The object type is a table. This is how I'm going to ask for things in the consumer account. We jump to our setup script. Here you can see we've got an application role here in line 6 and line 7. We're creating our version schema. Let me jump down all the way to the bottom here where we're running a bunch of grants for that application role. Here's how we're controlling what the consumer is able to see. Anything that I don't grant permissions to here, the consumer cannot see, okay? And you'll notice here we've got just DDL statements for all the other objects that comprise my application. So I've bundled those up into a setup script. Again, you can write very easy code to automate the compilation of this setup script. Then if we jump over here into this libraries folder that I told you to kind of pay attention to before, we've got some UDFs, we've got some procs, but let's look at the streamlet in a little bit more detail here. So first what I want to do is kind of point out that if we kind of scroll to the bottom here, here is how we are defining those references. So you can see I've got Python variables that are using this capability called reference order_table, reference site_recovery_table. If you remember from the manifest, those were the labels that I applied to these references that I'm asking for. So I'm now using those in my Streamlit file as Python variables. And where I can use them then is if we look up here, we can see that there is a SQL statement here on line 14. And if I kind of scroll here, we eventually get to how I insert the reference into the SQL statement so that whatever the consumer picks in their account is automatically going to get inserted into this SQL statement. So that's kind of references in action. So then that pretty much kind of covers all of the files that we have within this initial version that we published. But as we saw before, Dash and Unmesh gave us a faulty version. They were trying to trick us, make us look funny. So what we've gone and done now is gone out to version 101. So again, how and where you create this relative to source control and your build process, totally independent of how I'm showing it up here on the screen now. What I'm just trying to articulate here is that we've got now a manifest where we've got version 1, patch 1 defined. If we come in here, into our libraries and we look at the Streamlit, if we scroll to the bottom here, you can see I've corrected Google's to goggles. And for those of you who have memorized every HTML color, this is the blue that Dash originally showed in the Keynote demo, not the pink that he tricked us with. So I've already gone ahead and made those changes. Now what I'm going to do is hop over to the Snowflake VS extension that allows me to operate in my Snowflake account within VS Code. And you can see here, I've got my app package and my code schema, and I've got my stage. So here's my demo app stage. And I got my v1_00 directory out there and my v99. So what I'm going to do is I'm going to use the functionality built into here to select that, go one more up, make it easy for you to see that v101 directory. I'm just going to go ahead and push that whole directory up at one time. It's asking me at the top there if I want to auto compress or overwrite. I'm just going to accept the defaults. And what's happening is it's running that put statement right now. So it's pushing all of those files up into the stage so that I can reference them as the next patch version within my application. And you can see we now have our v101 codes here and we've got our structure in place. So now what I can do is walk you through a little bit of, how we sort of define these things. So the first thing that I'm going to do here in line 1 is I'm going to just switch to a different role that has permissions over the application package. I was operating under a different role before to kind of hide all the garbage in Snowflake in this account. And I'm going to go ahead and use my app package code schema, where I'm going to do the work to point to those files and create what is a new version. And since we got a resolution problem here, let's move this over a little bit so you can see all of line 4. So what I'm doing here is I'm running an alter on the application package to add a patch for version 1 using my files that are staged in that v1_01 directory. So I'm telling it, add a new patch using these files. So if I run that statement, it's going to go ahead and create that patch. And you can see here, patch added, version 1, patch 1. Again, patch numbers auto-incremented for you. Version labels, you can choose how you want to label your versions. So then I'm going to run this next statement here just again to make sure I'm in the right context. And what I'm going to do is create an application, a running instance of the application from my version 1, patch 1 files to make sure that my spelling correction and my color correction went into effect. Again, I'm in the provider account here. I'm not in the consumer account. So I'm basically going to be creating a test instance of the application to make sure we're good to go. So let's go ahead and run that statement at line 8. And this is going to run the setup script. So this takes a little bit more time because it has to instantiate this instance of the application. It's going to run that setup script. It's going to do all the things that it needs to do to set up things behind the scenes. And it will create an application instance for me called KM Demo App. And yay, demo gods. Oh, not too bad. Okay, it usually goes faster than that, but not too bad. Okay, so then the next thing that I want to show you here is I'm going to switch inside the application instance. So again, this is just a database. So I'm going to use a schema command to go to the app instance schema. That's the version schema, if you remember from the setup code before, inside the database. So I ran that statement. Now I'm in that application instance. And what I'm going to do here is show you how you can programmatically call those reference requests. So before we popped up the UI that says, hey, consumer, pick your table that I need access to. Here is how you can do it with a given programmatic call. And so I'm setting these references to those test tables that were in my dev database so that I don't have to worry about those modals popping up. So I run each of those statements. And now what I can do is come over here and look at the application. Now, first what I want to do, I promised I'd show you this before. This is the application package view in Snowsight. So before we were looking at the package from a database perspective. Now we're over here in this apps area and we get a little bit more information. You see we have V1, we've got 2 total patches. We haven't changed the default patch yet, so the default patch is 0 right now. We can see here at the bottom that there's an account that installed this application. That's the consumer account that I showed in the very beginning. And what we can also do here is look at our installed apps. So we see here that I've got this instance of the app that I just created off of patch 1. I'm going to go ahead and launch that. And this will not ask us for the orders table and the site recovery table this time because I already populated those references. So it's going to just jump right to populating the dashboard. And good news, I spelled goggles correctly, and we're back to a nice shade of blue. As you see, I like blue. I did not expect applause there. The last step that I want to show you is now that I'm comfortable with my application, that it's good to go, I'm going to go ahead and set the default release directive to use this new patch. What this will mean is that existing consumer account that I showed in the beginning will get upgraded. I'm not going to show that because we don't have time to show that in the demo. And any future new installs of this application will use patch 1 instead of patch 0. So if I run this statement, what this is going to do is it's going to set the default release directive so that this controls who gets installed on, what version. And again, there are more customizations that you can do to the release directive to set certain consumer accounts at different patch levels. Okay, that was the demo. Let's jump back over to the slides here and Scott will take us home.
Thank you, Kevin. All right, so I'm just going to jump into a few design tips. We've done the best we can to make building an application as easy as possible, but long story short, what we're trying to achieve here has some complexities to it. And there is a laundry list of design tips that are useful, but I think we just tried to pluck a few of the more interesting ones out to highlight here. So although Kevin didn't really go into the detail about it, we have a set of fine-grained access controls around application development. And what that means is think carefully about how you want the life cycle of your app to be managed. So we have the ability to separate who can develop the application versus who can define versions versus who's allowed to issue releases of the application, all the way up to who's allowed to manage the listing, which is the visibility of the application. You can be as coarse or fine-grained with these permissions as you like, but it's important to think about in advance. Application roles. These are also really critical to think about up front. They define your personas. They define, what are the classes of users or the classes of activities that you want your application to present. And once you've made that decision, it can be really hard to change it later because your consumers are already using the roles that you've defined. We didn't go into detail about this, but when you're writing the setup script, we put a few guarantees in place for you to make sure that to keep life sane. So as I mentioned about the whole version schema, that upgrades can happen while people are running the code. One of the things we allow is that between major versions, we ensure that there is no code running for more than one prior version. So what that allows is when you're writing your setup script, you need to be cognizant of the prior version, but only that version. But because of this, so patches don't get these same guarantees. Patches are assumed to be, you need it out right now. We can't wait for code to stop running. You're trying to fix something important, so they happen right away, which means at any given time, if you've deployed patches fast enough, you could have code for many patches running at the same time. So as a result, don't add features in patches because you don't get the same guarantees as you do with versions. Think through the app configuration. This is just a user, this is your consumer's first experience with the application. So, try to make the flow as clean as possible, the communication as clear as possible about why given permissions are needed and what the application is going to do with those permissions. Kevin highlighted debug mode. use it. It's super useful. If you really get stuck, basically what debug mode does is it shuts down the walled garden. So now you can climb over the walls and go poke at the seedy underbelly of the application and cycle very quickly trying to find a problem. And then once you found it, then package up as a version and test it in the real world without debug mode. Test. For these upgrade scripts, we say they are idempotent, but they're that way because you have to write them that way. And the only way to know you did it right is to test. And also, consider downgrade. Because of the way they're written, it should be possible to downgrade just by changing the current version to the previous version. But don't do it until you've tested. So we didn't show this in the demo, but Kevin did show it in one of the early diagrams. So, the application is running in isolation. So as a provider, the only means that you have at your disposal to understand what's gone wrong if a consumer has a problem is through logging. So we have a mechanism where the app logs locally in the consumer's environment, and the consumer can share those logs back to the provider in the event of a problem. And finally, Kevin touched on this in the data sharing model where you're sharing data from the provider to the app instances. If you've got a really complex sharing model, it's better to manage that data in a separate database outside of the application package. And there's a whole variety of reasons around that. But I think given the time constraints, I won't delve into those. But again, there's a lot of documentation about native applications. We'll be producing a lot more and a lot more tutorials to support you. But please familiarize yourself, and hopefully these tips will help you out. So with that, I'd like to thank everybody for coming here. And it's been a pleasure. Thank you.